Let's talk about finding the inverse of a 3 by 3 matrix. Now, a little reminder, this is way more complicated than a 2 by 2. And we talked about at the end of the last video, we actually have a 2 by 2 inverse shortcut that you can choose to memorize if you want to. But even if you do it this way, it's not that long of a process. However, 3 by 3 is much longer. So here's what we're going to do. We're going to take this matrix A. I'm going to erase this matrix bar. Put my regular bar, and then put my identity matrix after it. So this is what I've got now. And remember, I basically need to get the identity matrix to flip to this side. So essentially, I want to get this side into reduced row echelon form, which you should remember from 6.3. So if I need to get this side into reduced row echelon form, I'm going to use the same 3 parts, all the steps that I did in 6.3 to get reduced row echelon form. So a little reminder of those. First part is we focused on getting zeros on the bottom triangle half, right there, get those zeros in place, and we do that with those 3 steps. Then we focused on getting zeros on the top triangle, and we did 3 more steps. And then finally, once we had all the zeros in place, then we focused on getting ones on the diagonal by dividing all the things that we needed to divide. So here's what I would like you to do. I would like you to start with these first 3 steps. Here's our matrix. You've done these 3 steps before. You're going to do those 3 steps on this matrix so that you can get the zeros in those places where we want them. Then come back to check your work and see how you're doing so far. So you're doing part 1, these 3 steps to get zeros in those 3 places. Ready, go. Let's see if you're on the right track. So I did my first 3 steps right here. This is the matrix that I ended up with so far. Notice that I've got all my lower half zeros in place, which is what those 3 steps are designed to do. Get those 3 zeros in the right place. If you did not get this matrix as your answer, pause the video right now and check these steps to see where you went wrong, what happened. If you have the same line, but they're all like changed signs, but same numbers, that's totally fine. It's just like timesing the whole line by a negative. Now we move into part 2 where we need to get the zeros on top. Reminder that they're the same 3 steps as here. I'm just flip-flopping these 2. So instead of eliminating first column, replace R2, I'm eliminating second column, replace R1. So the 2 and the 1 flip places. And then same thing here, the 3 and the 1 flip places, and here the 2 and the 3 flip places. Now, I'm going to have you pause the video once again, go through these 3 steps. If you follow these 3 steps correctly, you should notice you'll get a bonus 0 somewhere where you can skip one of these 3 steps. That will tell you you're on the right track. So use this matrix we ended up with. Do these next 3 steps to get our upper half zeros in the right place, and then come back to check your work and see how you're doing. Let's check in and see how you're doing. So I did step 4, and I noticed, hey, I got 2 bonus zeros here. Since I have a bonus 0 right there, I can skip step 5 and move right on to step 6 where I get my last upper half 0 in place. So now I did part 1, zeros on the bottom. I did part 2, zeros on the top. The last step is to get 1s on the diagonal. So it looks like I'm going to divide everything in row 1 by 2. Divide by 2 so I can get that to be a 1. Divide everything in row 2 by 3 so I can get that one to be a 1. And row 3 already is a 1. Fantastic. So let's do those divisions and see where it takes us. So divide everything in here by 2. That gives me -1, +1, 0. Divide everything in the second row by 3. So -1, 0, 1. And the last row can stay because it's already a 1. And ta-da! We finally have reduced row echelon form, our identity matrix on the left-hand side. So we can now say that the inverse matrix is the matrix left on the right-hand side. Which is that. So, as I said, finding a 3 by 3 inverse is a much longer process, and there is no shortcut to it. It's actually the same process for a 4 by 4, 5 by 5, 6 by 6, everything else is to get all those zeros in the right place on this side, and then that side your inverse. So, hopefully you don't have to find too many 3 by 3 inverses, but now that we've practiced finding an inverse, we know how to find one. And then the last video for this lesson, we're going to talk about how to use the inverse to actually solve an equation, solve a system of equations. So I'll see you there.